Hello friends, I hope the previous video is not so boring. This video is very important in points of view. In this lecture video, we will discuss about the hydrogeology concept and terminology of the groundwater. Let's begin start. The lecture will cover the following topics. First, basics of hydrogeology, origin in rock, opening in rocks, subsurface water coordination, porosity and their types, basics of permeability, isotropic and anisotropic related to groundwater. Now let's begin. First, starting the basics of hydrogeology. What is the underground water? The definition of underground water: water below the surface at a pressure greater than atmospheric pressure, which flows freely into a hole through interconnected void spaces, is called groundwater. Okay. Then hydrology is a subdivision of the science of hydrology that deals with the occurrence, movement and quality of water beneath the earth's surface. Fresh water makes up only 2.5% of all water on earth, but not all of this water is available for human use. Groundwater is the second largest reserve, up to 30% of available fresh water on earth following the polar ice caps, that is the 68%. Subsurface opening large enough to yield water in usable quantity to wells and springs underlie nearly every place on the land surface and thus make groundwater one of the most widely available natural resources. Groundwater also represents the largest reservoir of fresh water readily available to man. The value of groundwater in terms of both economics and human welfare is incalculable. Consequently, its sound development, diligent conservation and consistent protection from pollutant are important concerns of everyone. Now, surface reservoirs and subsurface reservoirs for groundwater storage. The surface disadvantage of the surface reservoir: high evaporative loss even where humid climate prevails. Need large area of land, may fail catastrophically. If it is failed, then damage is very huge. Varying in water temperature, easily polluted, easily contaminated by radioactive fallout, water must be conveyed. Now, advantage of subsurface reservoir: practically no evaporative loss, need very small areas of land, practically no danger of failure, water temperature uniform, usually high biological purity, although pollution can occur. This pollution can be contamination of the groundwater, contamination due to arsenic contamination, radioactive decay contamination, that is contaminated by the some factories or others experimental lab. That is another thing we will discuss later. Water temperature uniform, usually high biological purity, although pollution can occur, not rapidly contaminated by the radioactive fallout. And this is not very sensitive to contamination of the radioactive elements. Act as a conveyance system, thus obviating the need for pipes or canals. Now, opening in rocks. There are two types of opening in rocks. First is the primary opening, second is the secondary opening. This is the volcanic rock, and this is a primary opening. The primary opening, if the voids were formed at the same time as the rock, they are referred to as primary opening. Okay. The porous material, well sorted sand, primary openings, purely sorted. And secondary opening, if the pore and sand, gravel and other unconsumed deposit, that is the primary opening support. If the voids were formed after the rock was formed, they are referred to as secondary opening. Okay. And fractured rock, fractured in granite, caverns in limestone. The most important example of the primary and secondary opening. This is the volcanic rock formed at the formation of the rock, and this is a secondary opening formed after the formation of the rock, that is limestone. And this is the picture overview of picture, primary and secondary opening. You can understand this is a surface water, this is a groundwater, land surface, received rock air, that is the rock, water not ground, held by the molecular attractions, surround surface of rocks, particles, approximate level of water level, gravel. These are the primary opening and extra. Now, subsurface opening, there are 6 types of subsurface opening. First, A is a well sorted sedimentary deposit having high porosity. B, purely sorted sedimentary deposit having low porosity. C, well sorted sedimentary deposit consisting of fragments of rock that are themselves porous so that the deposit has very high porosity. D, that is this one, well sorted sedimentary deposit where porosity has been diminished by the deposition of mineral matter in interstices. E, that is this one, rock rendered porous by solution, that is the solution cavities are present, this must be a limestone. And F, finally F, rock rendered porous by fracturing, and fractures are developed in the rock. Okay, that is the condition or possibilities of subsurface opening. Next one, the subsurface water regime, that is storage of water regime, can be followed by some rules, that can be followed by some concept. Okay. Vadose, the subsurface water can be deposited into 2 parts. First is the vadose zone, that is the unsaturated zone, and second is the saturated zone, that is the full with the water level, and vadose zone is a not full with the water level, that is the unsaturated part. It is also contaminated with, or it must be lying with the moisture content. If that is PW is the water pressure and PA is the atmospheric pressure. If the in vadose zone water pressure is less than the atmospheric pressure. Okay, the water beneath the surface can be essentially be divided into 3 zones. With the soils water zone or vadose zone, an intermediate zone or capillary fringe zone, and third, the groundwater saturation zone below the zone of aeration is groundwater saturation zone. And the water table is the imaginary line, imaginary surface divides the zone of aeration, that is the 2-part vadose and capillary fringe zone by the zone of saturation. The elevation of water table is determined to be where the pore water pressure PW is equal to the atmospheric pressure. At the water table surface, that is the imaginary surface, you can see that is the imaginary surface or physical surface. You can also say that is the physical surface because the water level has a surface where water pressure is equal to atmospheric pressure. That is called a water table. Okay, and below water table water pressure must be greater than the atmospheric pressure, and that's the reason of the flowing of the water, subsurface water. The general water table has undulating surface which generally follows the surface topography but with the smaller relief. Okay, next. And this is the cross section of the surface water. You can see clearly see in the vadose zone, that is the unsaturated zone, a capillary fringe where the capillary action has taken place, water table where the atmospheric pressure and groundwater pressure is equal to, and saturated pressure, that is phreatic zone, and this unsaturated part is called the zone of aeration. It's also a a cross section of subsurface water zone, that is the soil zone where the soil moisture is present, intermediate zone where the capillary action has taken place, and there is a capillary fringe, water table, and groundwater surface. Next, we will consider about the porosity. Porosity is a very important terminology to know the mysterious behavior, to understand of mysterious behavior of groundwater. Now, porosity. Generally, groundwater and soil moisture occur in the cracks, voids, and pore spaces of the otherwise solid earth materials. Porosity N is the percentage of the total volume that is void of material. It can, if the N is the porosity, that is simple formula 100 multiply by void spaces upon total volume of the rock. Okay. Now, porosity is a choice of selection. In this case, the porosity is large. In this case, the porosity is small. This also depends on the grain size and grain packing. Categories of porosity: primary porosity and secondary porosity. You know well. Okay, primary porosity. What is the primary? When a soil is first formed by the weathering of rock material and possibly subsequent biological action, the new entity will contain a certain inherent porosity known as the primary porosity. Similarly, secondary porosity: fracture or solution cavities formed in the rock or root tubes or animals burrows in soil may later forms and are known as the secondary porosity. Means secondary porosity is formed after the formation of the rock. And third is effective porosity. Not all the pores in the rock are connected. Only a certain fraction of the pores will allow the passage of water, and this fraction is known as the effective porosity. If the void spaces are interconnected to each other, that is called the effective porosity. Now, bulk density and particle density. It is a very important concept. People often confuse with the bulk density and particle density. What is the bulk density? Bulk density, ρ. The bulk density represents the density of the sediments including in voids. Recall that density is mass over volume, and the volume used in the bulk density is the volume of sediments plus voids. Okay. Now, particle density, ρs. In particle density does not include the voids but represent the density of the rock itself. Okay, clear? What is the bulk density and what is the particle density? Now, one important thing is the REV. REV is the representative elementary volume. To describe this terminology used to describe porosity or any other aquifer parameter, it is useful to first define the concept of representative elementary volume. The REV is a volume of aquifer over which the porosity, for example, is describable by a single value. For most rock and soil, the particle density is 2.65 gram centimeter cube. Now, looking at the combination of the particle density and bulk density, it is divided by the bulk density to the particle density. Then the mass of the sediment cancel to each other, and volume of sediment and REB, that is the representative elementary volume, is equal to, now REB or and ratio of ρb and ρs when the subtracted by 1, this gives a porosity. And the simple formula to obtain the porosity, N is equal to, in terms of the particle density and bulk density, volume of the voids to the representative elementary volume. And this method is called the gravimetric methods. It's a very famous method to know the bulk porosity of the rock. Now, rock porosity. how it varies in different medium. First, well sorted and sand gravel, it's a 25 to 50% porosity. It is very good for in terms of porosity. Sand and gravel, it's below the above one, 20 to 35. Glacial till 10 to 10, 20. Silt 35 to 50. Silt have the high porosity but the permeability is low. Clay, similarly clay is high porosity but the permeability is low. Now here the two crystal arrangement are showing. First the rhombohedral crystal and second is the cubic crystal. The cubic porosity is the largest porosity in any rock because it's contain the 47.67%, and rhombohedral packing porosity is the least porosity system in any rock. It is 25.95%. So then in terms of the porosity, the best arrangement of grain size for achieving a good porosity is a cubic porosity. Now some example of the primary porosity: sedimentary rock, that is the clastic, igneous rock, crystallines, metamorphic rock, it also found in metamorphic rock, volcanic rock, vesicles and etc. Secondary porosity: solution, this is the solution cavities, fracture purely carbonate limestone, contraction fracture, cooling basalt or flow, that is solution limestone. Now permeability. Before permeability, the concept of permeability in the groundwater flow is very important things. Permeability, as we name permeability, it gives the permit to the fluid to move in any medium. That is the general concept. Now what is the permeability? Permeability is the property of rocks that is an indication of the ability of fluids, that is gas or liquid, to flow through rocks. High permeability will allow fluids to move rapidly through rocks. Permeability is affected by the pressure in a rock. The permeability of a rock is a measure of its capacity for transmitting a fluid. The coefficient of permeability or hydraulic conductivity is defined as the discharge velocity through a unit area under a unit hydraulic gradient, and it's dependent on the properties of medium and the viscosity and density of a fluid. The permeability coefficient, that is the hydraulic gradient. What is the hydraulic gradient? We will discuss later and in deeply study about the hydraulic gradient and conductivity. But for basic knowledge, just listen this. The permeability coefficient of rock varies for different fluids depending on their densities and viscosities because of the presence of discontinuities in a rock mass. The permeability of a rock mass is controlled not only by intact rock but also by the discontinuities separating intact rock blocks. This can be clear from this picture. You see that the fluid is how the fluid is moving in a wide spaces of grain. That wide space is the porosity, and interconnected porosity is allowed to the fluid to move from one place to the other place. That is called the permeability. One thing, the porosity have a no unit but the permeability have a unit. Isotropic and anisotropic in terms of the groundwater movement. Hydraulic properties, hydraulic conductivity specificity, that is etc specific stories that will be discussing later, may vary through space within a geological formation. The spatial variation of hydraulic properties is called heterogeneity. There are many types of heterogeneous configuration in our geological environments. A good example is layered heterogeneity common in sedimentary rocks and unconsolidated lacustrine and marine deposit. If the geologic unit has the same hydrologic properties at all locations, this unit is homogeneous. Now that is the isotropic, that is the homogeneous, and anisotropic, this is the inhomogeneous, in which the property has changed in different direction, in which the property does not change in all direction. Anisotropic and heterogeneity, there are some possibilities, that is the four possibilities in isotropic and that is the first, isotropic and heterogeneous, this anisotropic and heterogeneous, isotropic and heterogeneous, anisotropic and heterogeneous. That is the four possibilities of the anisotropic and heterogeneous in the groundwater design. Okay. Now you can contact me in my mail ID if you have any problem. I hope this you will enjoy in this lecture video. Next we will discuss about the very interesting topic of the groundwater and aquifer properties. Okay, have a nice day.